In this video, we are going to see an important theorem, that is initial and final value theorem in Laplace transform. So first, let us see what is initial value theorem. So initial value theorem is used to find the initial value and final value theorem is used to find the final value. So first, initial value theorem. The initial value theorem is used to calculate the initial value x of 0 of the given sequence x of t directly from the Laplace transform. That is, using this relation we can find x of 0. So limit s tends to infinity, s into x of s is equal to x of 0. So by applying this limit in s into x of s, you will be getting the value for x of 0. The next one is final value theorem. The final value theorem states that limit s tends to 0, s into x of s is equal to x of infinity. That means this is the final value, x of infinity. So by applying the limit s tends to 0 in s into x of s, you will be getting x of infinity. So first problem, determine the initial and final value of the signal x of t whose unilateral Laplace transform is x of s is equal to 2s plus 5 divided by s into s plus 3. So here the Laplace transform is given. So by using the initial value theorem, x of 0 is equal to limit s tends to infinity s into x of s. Always remember, if you want to find the initial value, we have to apply the limit as infinity. If we need to find the final value, means then we have to apply the limit as 0. Right? Then x of 0 equal to limit s tends to infinity s into x of s. So limit s tends to infinity s into, what is x of s? 2s plus 5 divided by s into s plus 3. Now we have to apply the limit. So if we directly apply the limit, what happens? The whole term changes to infinity. So what we are doing means, in the numerator take s outside. So you will be getting 2 plus 5 by s. Similarly, in the denominator also take s outside. So you will be getting 1 plus 3 by s. This s and this s gets cancelled. Now we have to apply the limit. So 1 by infinity equal to 0. Therefore, the answer is 2 divided by 1, that is equal to 2. So the initial value is 2. Next we are going to find the final value. So x of infinity equal to limit s tends to 0. So if you want to find the final value, you have to substitute the limit as 0, s into x of s. Again you have to substitute the value of x of s. Now we have to apply the limit s tends to 0. So if we apply the limit s tends to 0, you will be getting 5 divided by 3. So this is the final value. Next problem. Determine the initial and final value of the signal. So x of t equal to sine 2t into u of t. Now we know the formula for initial value, x of 0 equal to limit s tends to infinity s into x of s. That is, we have to find the Laplace transform of x of t. So Laplace transform of x of t is x of s is equal to 2 divided by s square plus 4. That means sine omega t Laplace transform is omega divided by s square plus omega square. So in our problem we are having omega equal to 2. Therefore 2 divided by s square plus 4. Now apply the limit. X of 0 equal to limit s tends to infinity s into 2 divided by s square plus 4. So if you apply the limit, you will be getting the answer as 0. Final value, x of infinity equal to limit s tends to 0 s into x of s. Limit s tends to 0 s into 2 divided by s square plus 4. So here also by applying the limit, you will be getting the answer as 0. So here initial value and the final value is equal to 0. Next problem, determine the initial value x of 0 for the following Laplace transform. So they are asked to calculate the initial value alone. So x of s is given. So limit s tends to infinity s into x of s. So s into 3 divided by s square plus 5s minus 1. Now we have to multiply this s inside. So you will be getting 3s divided by s square plus 5s minus 1. So from the numerator you are having an s. In the denominator you have to take s square as outside. So if you take s square outside, you will be getting 1 plus 5 divided by s minus 1 by s square. Now 1 s gets cancelled. So you will be getting 3 by s divided by 1 plus 5 by s minus 1 by s square. Now we have to apply the limit. So if you apply the limit, 1 by infinity is 0. So you will be getting the initial value as 0. Second problem, x of 0 is equal to limit s tends to infinity s into x of s. So limit s tends to infinity s into x of s, you have to substitute here, then you have to apply the limit. Just simplification. In the numerator, you have to take s square as outside. So you will be getting 2 divided by s plus 3 divided by s square. Denominator also s square. So 1 plus 5 by s plus 6 by s square. Now we have to apply the limit. S tends to infinity. So you will be getting the answer as 0.